Okay, this video is for period 3, Algebra 3-4. This is just a review for the exam that you guys are going to be taking on Friday for you guys to review while I am on the road to go to Modesto. So you should be doing sections 11.1 through 11.8 today. So I'll just give you guys a couple of examples from each section. That way you guys know kind of what's expected of you. So let's just take a look at number 1 here. The problem is 9, 7, 5, and they're asking you to find the next 4 terms of the arithmetic sequence. From here, it's pretty simple. You need to identify your common difference as -2, right? Because we're subtracting 2 every single time. So if we're going to write the next 4 terms, then the answer is going to be 3, 1, -1, -3. So that's 4 terms. That's all you need to do. So that'll probably show up on the quiz in some form, so just make sure you guys know that. Let's go ahead and jump forward to number 5. They're asking you to find the nth term of the arithmetic sequence described. So in this problem, they give you a sub 1 equals 4, d equals 5, and n equals 10. So in order to do this problem, you need your arithmetic sequence formula, which is a sub n equals a sub 1 plus d times n minus 1. Alright, so let's go ahead and pump all these things in. They're asking you to find the nth term, so which means they're asking you to find the 10th term since n equals 10. So let's go ahead and plug all these things in. So it's going to be a sub 10 is equal to a sub 1, which is 4, plus d is 5 to the n minus 1. So that is 10 minus 1. Oops. Okay, so that's going to be a 9, so 9 times 5 is 45, plus 4, so you're going to get an a sub 10 equals 49. And that's as far as you need to go for that problem. Okay, let's go ahead and move on from there. Actually, you know what, let's take a look at number 11. I like number 11. Okay, so it looks like 3, 5, 7, 9. Okay, we're trying to write an equation for the nth term in the arithmetic sequence. If you remember to the very first lesson on this, we were able to derive this formula. So we were able to identify this as a sub 1 and a sub 2 and blah, blah, blah. The distance, the common difference is 2, so we were able to say that a sub 1 is equal to 3. A sub 2 is equal to 3 plus 2. A sub 3 is equal to 3 plus 2 times 2. Whoops, running out of... That's ugly. Times 2, blah, blah, blah. So a sub n is equal to 3 plus 2 to the n minus 1. Okay. And so from here, we can say that a sub n is equal to a certain formula. So we can say that 2n, we can say 3 plus 2n minus 2. We can distribute that. And then we can just go and combine like terms. So a sub n is equal to 2n plus 1, looks like. So that is our formula for this arithmetic sequence. Okay, so let's go ahead and move on to section 11.2. 11.2 is arithmetic series, so we are now doing the sum of the sequence. So now let's go ahead and bust out our arithmetic series formula. So s sub n equals n divided by 2 times a, this thing is bugging out, a sub 1 plus a sub n. So I'll go and give you guys an even one, even though I didn't assign it. Can't be doing all the homework. That would not be appropriate. A sub n equals -12, and then n equals 30. Okay, so now they're trying to ask us to find the whole sum. So let's pump in what we can. I think we have enough information to get what we need. So s sub 30 is going to equal n over 2, so that is 30 over 2 times a sub 1, which is 15, plus a sub n, so that's plus -12, or quite simply minus 12. So we've got, looks like, a 3 here. 15 minus 3. So we can say that this is 15, so 15 times 3, s sub 30, so the sum of the first 30 terms is 15 times 3, which is 45. Okay, let's move on. So that was number 2. The only thing they can really do, remember, in these problems is to take away information from you, but they'll always give you enough information to be successful on the problem. So let me see if I can find one that does exactly what I am saying. It does not. Okay, so let's just move on to number 7. Okay, so number 7 here looks like we have a 3 plus 12 plus 21 plus 30 plus dot 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 plus 57. Okay, so they've taken away a lot of information from you. But we can figure out a sub 1. We can figure out a sub n. And you know what? We can figure out d at the same time. So remember, a sub 1 is 3. A sub n is 57. It's the last term. And d is going to be, looks like, 9. Now, why did I need to find d? Well, d is going to help us find our n term, right? Because as of right now, if I was to plug all the information in, it would look like this. It would look like s sub n is equal to n divided by 2 times 3 plus 57. So I'm missing this n right here. So I need to be able to figure it out. So we need to go back to our sequence formula from before, which was a sub n equals a sub 1 plus d to the n minus 1. So I hope you're able to follow that so far. I had to pull this formula up in order to find out what n is. So a sub n, we're going to do a little bit of side work here. No space. A sub n, which is 57, is going to equal a sub 1, which is 3, plus d, which is 9, times n minus 1. So I'm going to go ahead and subtract 3 from both sides. So I get 54 equals 9 times n minus 1. You can go ahead and distribute. I choose not to. I'm going to divide by 9. So I get 6 equals n minus 1. So n therefore equals 7. Now that I have found n, I can plug that into this formula here. So n is 7. So what we get here is we get 3 plus 57, which is 60, times 7 over 2. Those are going to cancel. I get a 30. 7 times 30 is 210, and that is your answer. So, most important thing about this particular problem is they didn't give you a sub 1 and a sub n explicitly, but they made you find it on your own. Plus, you had to find out d in order to plug it back into the sequence formula so that you could figure out the rest. Oh, so that you could figure out n and finish the problem. So make sure you guys keep that in mind for the quiz Friday, should I ask you a question like that. Number 10 from 11.2, it says write the terms of each arithmetic series and find the sum. So since they're asking you to write the terms, they're basically asking you to kind of brute force this thing. So if I say that n equals 1 to 6 and this series is n plus 2, what I'm going to do is I'm going to do all of these from 1 to 6. So that looks like this. 1 plus 2. 2 plus 2. Remember, n is the only thing that's changing. 3 plus 2. 4 plus 2. 5 plus 2. 6 plus 2. Now remember, sigma here means summation, which means that all of these terms are going to be added together at the very end. So let's go ahead and figure out what each of these things are. So 1 plus 2 is 3, 2 plus 2 is 4, 5, 6, 7, and 8. So when I add all those things together, what I get is 33. Now, remember on the quiz, you do have to write out all the terms in order to get full credit, so make sure you show me all of the work necessary. Okay, let's jump into 11.3 now. So we've got 11.3. Geometric sequence, so which means we're going to need this formula, this a sub n equals a sub 1 times r to the n minus 1. Okay, so we're going to need that. So find the next 4 terms in the sequence. So this is let's do number 2. 2, comma, 10, comma, 50, comma, dot, dot, dot. So from here, you should be able to identify that the common ratio, right, because r is used in a geometric sequence, the common ratio is times 5. So the next 4 terms in the sequence. Now, You'll be multiplying by 5 every single time. You're going to get some really large numbers. Please remember, you will be able to use a calculator on the test. And you will not be able to share calculators or use a cell phone as a calculator. It is on the internet now, so you can't say I didn't tell you. Next one is going to be 250. Next one is going to be 1250. Next one's going to be 6250. And the last is going to be 31,250. And those are your next 4 terms in this sequence. Okay, next, let's jump to number 6. Find the nth term in the geometric sequence described. So a sub 1 equals 200, r equals -1/2, and n equals 10. So we're just going to plug and chug into this formula here. So a sub 10 is equal to 200 times r, which is -1/2 to the n minus 1. So that is 10 minus 1, which is 9. Now, please remember that if I give something to you in fraction form, I expect you to leave it in fraction form the whole time. So with a problem like this, how do you do this in a calculator? So what you do is you say a sub 10 is equal to 200 times, now this is a negative, all right, and a negative raised to an odd power is going to be a negative. 1 to the 9th power is 1, obviously, like Teacher Joseph told Teacher Stacy. That ice cream goes in the freezer, obviously. And then in your calculator, you just go 2 to the 9th. 2 to the 9th is 512. So from here, you multiply straight in. A sub 10 is equal to 200 over 512, which is negative. And then you just do that in your calculator. And then you can go fraction to decimal, especially if you have one of those smart TIs or the communist Casio calculator, which becomes -25 over 64. Okay, so that is number 6 for your viewing pleasure. Let's jump to 11.4. Says find S sub n for the geometric series described. Now, 11.4, remember, was the finite geometric series, so S sub n is the formula we're going to use. It's going to be a sub 1 times 1 minus r to the n all over 1 minus r. So that's the formula we're going to be using in this particular section. So let's go ahead and do number 2. That's an easy one. So a sub 1 equals 1, r equals -2, and n equals 7. You plug and you chug. S sub 7 is equal to a sub 1, which is 1, times 1 minus -2 to the n, which is 7, all over 1 minus -2. Now you have to be careful here in these types of problems, because if you say 2 to the 7th or -2 to the 7th, that is -128. So what you have is you have 1 minus -128, which is 1 plus 128, which is 129. So you really have 1 times 129, which is 129, over 1 minus -2, which is 3. So 129 divided by 3 is, in fact, 43. I do want to do one with a fraction as our ratio. So let's see what happens. Let's do number 4. A sub 1 equals 27. R equals -1/3. N equals 6. So we're going to use that same formula. Whoops, I accidentally deleted it, but you should have it on your paper. S sub 6 equals a sub 1, which is 27, times 1 minus -1/3 to the 6th power, all over 1 minus -1/3. Okay, Remember, this part here is relatively easy. Negative anything to an even power is going to be positive, so we can go ahead and make that positive. 1 to the 6th is 1, obviously, like putting ice cream in the freezer, obviously. 3 to the 6th is 729, so a 729 is going to go on bottom. So what I have here in this box here is 1 minus 1 over 729. So I'll go and clean that up a little bit. I really have 1 minus 1 over 729. So does it make sense that my common denominator is 729? So I really have to do 729 over 729, which is 729 minus 1, which is 728. So 27 times 728 over 729. All over 1 plus 1/3 is 4/3. Okay, so I'm going to take a hunch and say that 729 can be divided by 27. It can be. Those two are going to cancel each other out. What I have is 728 over 27. They canceled each other out, leaving me with 27 on bottom. All over 4 over 3. Now, I'm going to flip and multiply, because that's how I do complex fractions. This is 728 divided by 4, which is 182 up top. Those cancel each other out. And then the 3 and the 27 gets you the 9 on bottom. I just realized that the answer to number 4 was actually negative 182 over 9, and that is because the a sub 1 is not 27, a sub 1 is negative 27. So when we do the whole cancellation, it'll be negative. So, whoops. Cool. Let's take a look at something like number 20. So, we're going to write the terms of each geometric series and then find the sum. So let's go ahead and do our sigma, and then again, that's a nasty sigma. There we go, that's better. So n equals 1 up to 6, and then you get 1/2 to the n minus 1. Okay, so again, they're asking you to write the terms, so they're asking you to brute force this thing. So this is really 1/2 to the 1 minus 1, and then 1/2 to the 2 minus 1, and then 1/2 to the 3 minus 1, then 1/2 to the 4 minus 1, 1/2 to the 5 minus 1, and lastly 1/2 to the 6 minus 1. Now remember, I went from 1, because that's where it told me to start. That's where this 1 came from. And then I went up to 6, because that's where it told me to end. And remember, this is a summation, like the last problem. So we're going to be adding up all these terms. So let's figure out what each of these things is. Each of these things are, actually. 1 minus 1, 0. This thing's 1, piece of cake. This thing is 1/2. This is going to be 2, so 1/2 squared is 1/4. This is going to be 3. 1/2 to the 3rd is going to be 1 over 8. 1/2 to the 4th is going to be 1 over 16. 1/2 to the 5th is going to be 1 over 32. After you find all the common denominators and all that good stuff, the common denominator in all this is 32. Your answer will be 63 over 32. Okay, let's move on to infinite series. Do a couple of examples from there. Okay, it says find the sum of each infinite series if it exists. So, first thing they might do is they might give you a couple of easy ones. They might say, number 1, 54 plus 18 plus 6 plus ... How do you find r? Well, a sub 1 actually first is easy. That's 54. That's obvious. Like putting ice cream in the freezer. How do you find r? Well, r is easy to find as long as you just take the first term or the second term and divide it by the first term. So if we go, and actually, you know what? In this case, it's easier to take the third term and divide it by the second term because the numbers are getting smaller. So 6 over 18 is 1/3. So r is 1/3. Now, you can tell that this series converges Because r is a fraction that is less than 1. Remember, r must be between 1 and negative 1 and 1. It can't be equal to, that's not true. It has to be in between them, but not including. So if it doesn't meet this, the series diverges, and you don't have a sum for an infinite series. So the formula you use to find the sum of an infinite series is s equals a sub 1 over 1 minus r. So this is easy. S should equal 54 over 1 minus a third, which is 54 over 2/3, which is 54 times 3 over 2. That is 27. 27 times 3 is 81. And you are done. And done. Okay. Let's take a look at something like 14. Actually 13. Actually 14. Goes to infinity. N equals 1. 5. And then negative 1/10 to the n minus 1. Because it is set up like this, and because it's algebra 3-4, we should know that a sub 1 is going to be 5, right? It's this term right here. R is the thing inside the parentheses in this case, negative 1/10. It converges. Converges very, very quickly, actually. Okay. So S is going to equal 5 over 1 minus negative 1/10. So that is positive. So that is 5 over 11 over 10, which is 5 times 10 over 11, which is 50 over 11. I apologize for the sloppiness and the quickness, but we are on a time crunch. Okay, last type of problems are binomial expansion. So let's move on to it. Okay, let's go ahead and expand one of these binomials here, 11.8. So let's take a look at number 10. 2x minus y to the fourth. I will tell you now. Look to your Pascal's triangle. The coefficients are 1, 4, 6, 4, 1. Each term gets a set of parentheses. Remember, you're just on an assembly line, like Lucy was when she was trying to make those chocolate boxes in I Love Lucy. 2x, negative y. 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 Remember, the first term always starts high and goes low. So 4, 3, 2, 1, 0. The second term starts low and goes high. So 0, 1, 2, 3, and 4. So now you just simplify. 2x to the fourth, well, y to the 0 is nothing. This is 16x to the fourth. Now you have 8x to the third times 4, so 32x to the third y. But remember, negative y is being raised to the first, so it's going to be negative. 2 squared is 4 times 6 is 24x squared y squared. Now, because the negative y is being squared, it's going to be positive. 4 times 2 to the first, well, 2 to the first is 2, times 4 is 8x y to the third. And because y is being raised to an odd power and it's negative, it's going to be negative. All this garbage goes away, plus y to the fourth, and you are done. And done. Okay, let's find the indicated term of the series. So let's take a look at number 12 here. This is the last problem. Let's see. Ooh, that's kind of an awful problem. X plus 3 to the 8th. And they are asking us to find the 6th term. For this, we use the formula summation from k equals 1 to n, and it's n factorial over parentheses n minus k factorial times a to the n minus k times, that should be minus b to the k. That's the formula you learned yesterday, so make sure you have that in memory. Hardest part of this problem is understanding what n and k r. Remember, n is the exponent that they give to you. K is always one less than what they give to you. Right? Sixth term, K's got to be 5. Okay, so let's pump it into our summation formula here. So we've got summation from K equals 1 to 8 of 8 factorial over 8 minus 5 factorial K factorial times A, whoopsie, not A. In this case, A is replaced by X to the n minus K, so that is 8 minus 5, times B. Well, B is 3 to the K, that is 5. You will need a calculator for this. Let's expand this out. 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over. This is 3 factorial, so that's 3 times 2 times 1. Whoops, did I leave that as a K? I meant 5 factorial. So this is times 5 times 4 times 3 times 2 times 1. Okay, the 5, 4, 3, 2, 1s are out of there. 3 times 2 equals 6. So what you have really is 56 x to the third, and then 3 to the fifth is 243? 243. All that's left is to multiply those two together. 56 times 243 is 13608 x to the third. And that is your answer for a binomial expansion. Okay, hopefully you are able to do the worksheet on your own or the assignment on your own. Good luck.